the integral of an absolute value function. I'm going to draw a picture because I feel like that's really helpful. Let's graph what x plus 1, what the absolute value of x plus 1 would look like. Now, a plus 1 in the mother function of absolute values, so it'd be x minus b absolute value. Actually, it's not usually b, it's h. And then you add a k, and then you have an a multiplying out here. Right now, a is 1. The h is negative 1, so that it would be a plus 1. And then k is 0. So where our horizontal shift is going to be to the right, 1. And then, boom, we have our graph. And what we're going to do is we're going to go from negative 2 to 3, and we're going to find the area underneath the curve. Now, I drew a picture to help us see where this function inside the absolute value bars crosses the x-axis. Really, wait, did I move it the wrong way? I totally moved it the wrong way. Dang, I almost did that totally wrong. We're not moving to the right, we're moving to the left. Shoot. Okay, so because it's negative, h is negative 1. So negative 1, there you go. Okay, that's better. Wow. Did anybody catch that? You guys are going to tell me that in a little bit after I got halfway through solving the problem. Okay, so we have to know the x-intercept of what's inside the absolute value bars. So what you could do for these absolute value functions is you could always take what's inside and set it equal to 0 to see where the x-intercept is. So here the x-intercept is at negative 1. That's where this guy has to flip up so that we have so we obey the absolute value rule. So at negative 1 is where this integral is going to get split up. So you're going to have one integral, which is going to be for the first one. That's going to go from negative 2 to negative 1. And the integrand, I'm going to leave it blank for a second. And then the other integral, which we'll make orange, will go from negative 1 to 3. Okay. So what would that be? That would be x plus 1, because that's a normal function that's inside of it. So what would be this one right here? What would be that rule? It's going to be this guy, but negative. It's going to be the opposite. So I'm going to put a negative out in front. That is what's going to make this line go up instead of continuing to go down. This guy would continue to go down. But the absolute values make it go above the x-axis. So I would actually write this by changing the sign of each of those. So it would be negative x minus 1 dx, and then do this guy. So we got to do each of these integrals, and then add them together. Then we're done. Okay, so for the first one, this would be x to the second power. Still negative, divided by 2 minus x, and we're going to plug in negative 2 and negative 1. I should have just messing up all the colors. All right, we'll just stay orange here. And this one's going to be x to the second power divided by 2 plus x, and we're going to plug in negative 1 and 3. Okay, doing the reverse power rule, that's how I got those. And then this one, let's see, let's plug in the negative 1 first. So I plug in negative 1 to this would be a positive 1. So we get negative 1/2 minus plus 1. So that's what I get when I plug in negative 1. Then I'm going to subtract. Now I'm going to plug in negative 2. When I plug in negative 2, I get positive 4, but then negative 4. So it's going to be negative 4 divided by 2. So we get a negative 2. Don't forget your parentheses. And then I plug in negative 2 to this x. It's going to be a positive 2. So I'm adding 2. Cool, those guys cancel out. Now going over to this guy, we're going to plug in 3. We get 9 over 2 plus 3, parentheses, subtract. Plugging in negative 1. We already did that once. We got this. So you could... No, actually, it's not going to be the same thing because this is different. Okay, never mind. Okay, so negative 1, I plug it in there. It's going to be positive 1, so we get 1/2. And we get negative 1. Make sure you put your parentheses around that. Okay, so boom. Let's distribute the negative for that one. We'll distribute. Actually, this is 0, so we don't have to do that. So we get positive 1/2 for that first one. For the next one, we have 9 over 2 plus 3, and then we have plus. This is going to give us a positive 1/2. So let's simplify some more. This and this is 1, so we have 1 plus 3, which is 4, plus 9 over 2. And it looks like our answers are all improper fractions, so that's the method I'm going to use. I'm going to make an improper fraction. Common denominator would be 2, so we have 8 plus 9, which is 17, divided by 2, and that's your answer.